Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to be talking about dihydroxylation reactions onto alkenes. In this case, we'll be using the osmium tetroxide reagent. You might recall in the last episode that we talked about. So the osmium tetroxide is an electrophile. It is an example of an inorganic reagent, and it uses and produces diols. These are also known as glycols. These reactions involve the syn addition of two alcohol groups onto an alkene to make that diol. Now, seeing that syn addition gives you a hint that this reaction is going to be stereospecific, and there's going to be a concerted reaction mechanism where bonds are breaking and forming at the same time. And this is a syn addition as opposed to the epoxide ring opening, where there's an anti-addition, where you have that. So first of all, to give a broader context of synthesis, suppose we were trying to make this alkene here. A reasonable starting material could be this reagent, and you can use a small base, like sodium hydroxide, to do an elimination reaction, and you arrive at the alkene. This alkene can react with osmium tetroxide to afford this diol. So how does this reaction happen? So first of all, the reagent osmium tetroxide looks like this. Okay, and this can undergo reactions with the alkene. So in short, the lone pair on this oxygen attacks this carbon. The pi bond on the alkene will attack the oxygen and push electrons back onto osmium. This produces an intermediate that looks like this. And in the second step, where we just add water, which is known as a hydrolysis process, you end up at this product directly. Now, the mechanism at this stage is a little beyond what you're expected to know in Organic Chemistry 1. What I would focus on remembering is that this is a concerted cycloaddition reaction that gives a stereospecific product, which in this case is the syn diol. So once you produce this diol, you can do all kinds of different reactions, which will be the subject of future episodes. If you want to ask more questions in your office hour, I suggest asking, well, what's the full mechanism of this reaction, especially that second step? 2, is osmium tetroxide air sensitive? Could you do this reaction on a benchtop? And can this reaction used on all alkenes? Are there some alkenes electron rich or electron poor, or sterically bulky alkenes where this reaction won't work? Well, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.